Hi, I'm Leigh Johnson. I'm the chair of the Math, Computer Science, and Physics department here at Capital University.
I'm David Reed, professor of computer science at Capital University. Most of our students end up doing software development. So our intro courses have an intro programming course, which we currently use Python. We switched to that about 20 years ago and found it worked really well. We then have a second course that uses a mixture of Python and C++ for our algorithms and data structures course. Those two courses sort of form the foundation for every other course. They're essentially the prerequisites for everything else. And then we have a software design course, a second course in algorithms and data structures. We have a database course. We have a computer architecture course that helps them understand what's going on inside the computer. Most of our students don't end up doing computer architecture, computer hardware, but we do have a 3-2 engineering program where students take the computer science classes and the corresponding science classes such as chemistry and physics at Capital University during their first 3 years. And then they spend 2 years at an engineering school to take just engineering classes, and then they get a degree from both universities. Most of our students do that at Washington University in St. Louis. We also occasionally have students go to Case Western Reserve in Cleveland. Some of our other upper level courses include a programming languages course that helps students understand how to learn new programming languages. As you get out in your career, you'll notice that the language that you learned here may or may not be the ones that are still currently used in industry. They change very rapidly. We also have a computer graphics course that teaches a little bit about how 2D and 3D shapes are drawn on the screen. That's also useful for doing user interface development. We have an operating systems course and a parallel computing course. In the operating systems course, you're not learning operating systems or writing operating systems, but you're trying to understand how they work. How do they allow multiple programs to run at once without conflicting with each other? The parallel computing course has become more important over time as we look at, all the computers, even your phones, have multiple CPUs, multiple cores inside them. How do you write software that can take advantage of that? And again, is a lot more complicated than it seems because you have to make sure that something running on one core doesn't conflict with the other core. So those are kind of the upper level courses we have to help students learn those technologies and understand how those things will work over time. We have 5 elective courses and students need to take 6 credits. So generally they take 2 of those courses. We have a course in Java, since Java is still a popular language that's used today. We also have a course in networking to understand kind of the low-level details of how the data is transferred over the network between computers and wirelessly. We have a follow-on course to that in computer security for students who are interested in cybersecurity. Cybersecurity is often a job that is learned sort of on the job. You kind of need to have the background to understand how computers work and what happens, but kind of the actual details of how do you stop intrusions, detect intrusions, those types of things are generally learned on the job. We have a course in artificial intelligence, which is obviously a hot area these days, and an elective course in Swift and iOS development. All our juniors and seniors take 3 credits of our junior-senior seminar. That course allows students to explore topics that are of interest to them but wasn't covered in our core curriculum. Some of our students do projects in web development. Some of them do advanced versions of some of our courses. Just all depends on what the student is interested in. So in addition to seminar, all our students take a set of signature learning classes that every major takes. These include courses in writing, speech and communication, and various other topics. Those courses, in addition to our seminar course, where students present the project in their last semester, help prepare them for interviews and how to speak and communicate effectively at their first job. That's one of the things a lot of the employers that come to us, the reason they do come to us is they're happy with our students. They know that they can communicate. They know that they can work together with a team versus students who might be that stereotypical want to sit in a cubicle and not communicate. In addition to the computer science classes, our majors are required to take 3 math classes, Calculus 1, Statistics, and Discrete Math. A math minor requires 6 courses, so many of our students end up completing a math minor also. The major is structured in such a way that 1/3 of your classes are computer science classes, about 1/3 are the signature learning classes, and that leaves another 1/3 for whatever classes you want to take. As we mentioned, some students do a minor in math, some students do the data science minor, some students also will complete a double major in areas such as business and accounting. That flexibility allows them to take whatever other courses interest them. We've also had a number of students from music technology take some computer science classes. Some of them end up minoring in computer science, and some of them also end up double majoring in music technology and computer science.
So many of our students add a data science minor. Data science is a mix of computer science and statistics, and then you take that and you apply those data skills in a field like biology or business. Many of our business students actually come over and do the data science minor. The data science minor consists of 2 courses in statistics, a computer science course, a course in databases, a course in data visualization, and a course in data science. And then when you've completed all of that, we have students do a capstone requirement, which is either an individual data analytics project or an internship in the Columbus area. We've had data science minor students do their capstone requirement at CODA, which is the local bus system. We've had a student do one at NetJets, which is a private plane company that's very big in town. We've had someone at Nationwide Children's Hospital. So there are many, many jobs right now in Columbus. Employers are looking for candidates who have these skills. Our students are really great candidates because in addition to having the computer science skills and the data science skills, they also have to take a core liberal arts set of courses like communication and writing. And so we've gotten a lot of great feedback from employers that our students can communicate clearly, and they really appreciate that our students have those skills. And so we've been very successful at getting students into positions in the Columbus area in data science or data analytics kinds of positions. One of the great things about being in Columbus is that even beyond Capital, there are lots of opportunities for education. Of course, I mentioned the internships, but there are things like meetups where you can meet with other people who are in the field and learn from them what it's like to be a computer scientist or what it's like to be a data scientist in the real world. We have conferences that we send our students to actually as part of our seminar, and they get a chance to see professionals either in mathematics or computer science or statistics, what some of their research is and what they're doing. There's a Data Connect conference that happens every year in Columbus during the summer, and that's a great opportunity to learn more about data science, which of course is my field. So there are lots and lots of opportunities to learn about the field at Capital, but also to learn about the field in the real world and what's happening and to have that knowledge. For the data science minor, you will get a chance to learn the R programming language. You'll get to learn Tableau. You'll get to learn Power BI. You'll learn Excel as it applies to the data science field. So you do learn a lot of different applications, although of course they're changing. So for example, in our data visualization class, you learn Tableau, you learn Power BI, but the focus is really not necessarily on the application or the technology. It's more about what makes a particular graph an effective way of communicating data. Data storytelling is very big these days. And so you learn those skills while at the same time learning actually how to do those graphs in Tableau or Power BI or Excel.
One of the most important skills to be successful in computer science is problem solving. It doesn't necessarily matter what courses you take in high school, as long as you develop those problem solving skills. Some of the things we often see in students that are successful is they like to understand how things work. They like to take things apart, figure out, look at them, put them back together. Those types of problem solving skills generally transfer directly to being successful in computer science. Some math problem solving skills will help. Doesn't necessarily mean you have to love math and be an expert at math, but they often are good complements of each other. But if you don't like math, it doesn't mean you can't be successful at computer science. What is important is you like the problem solving aspects of it. Most of our students end up working locally in various software development jobs. These can vary from some of the insurance companies in Columbus, such as Nationwide. Some of our students go to a local research lab called Battelle, but there's also hundreds of small companies that I've never heard of that students get jobs at. I'm always interested in finding out. A student say, oh, I got a job here, and I've never heard of that company, but then they end up hiring 2 or 3 of our students afterwards. There's lots of job opportunities here in Columbus, from insurance to banking to all kinds of other small companies. As I mentioned earlier, some of our students do the 3-2 engineering program if they're interested in hardware and engineering, where they spend 3 years here and then 2 years at Washington University in St. Louis. Some of our students also go on to grad school, some here in Ohio and some out of state. Most of them are completing master's degrees, but we have had 1 or 2 students in my time here complete a PhD. Computer science is a rapidly changing field. As a result, students have to want to learn new things constantly. It's one of the things that we strive to prepare students for, is to be able to develop those new skills and how to learn new skills over time. Obviously, with the rise of artificial intelligence, many people are expecting the field to change even more rapidly in the future. Those problem-solving skills are still going to be important. The computer may write some of the small programs for you, or small parts of it. That's even happened over the years since when I was in college. For many years, programmers had to write low-level software, and currently we have libraries, they're often referred to as the standard library for the programming language, that allows people to not have to write that low-level code and instead focus on the higher-level code. And that often involves designing the system. Sort of like an architect designs buildings, you have to design how the different pieces of software are going to fit together. Artificial intelligence may be helpful writing some of the small pieces, but right now it doesn't yet appear it's going to be successful at designing these large systems. With the development of the Intel plant near Columbus, we've seen a large number of associated technology companies also move into town. This will create a wide variety of new opportunities for computer science graduates. One of the big benefits of Capital being in Columbus is that there are many small companies and large companies here that hire student interns. It allows you to apply what you've learned in the classroom and get real-world experience, and often that experience can lead to a first job, or that ability to have that on your resume to help you find a different first job.
One of the wonderful things about Capital University is that we are a small school, so you have small class sizes. We have dedicated faculty who love teaching. Most of the classes you would be in wouldn't be more than 12 or 15 students. So you get to know the professors, you get to talk to them. For our seminar, you actually work with one of our faculty members on your project. So there are lots and lots of opportunities to really get to know your professors and feel comfortable here and feel supported. We hope you find this video helpful in learning a little bit about our campus and our major and some of the opportunities that are available here for you. We look forward to hearing from you and welcoming you to our campus.